So we are still on the line of having legends on stage, people who have been doing cybering for long time. Next presenter comes to us from Finland, Mikko Kenttäla, who's going to talk about finding vulnerabilities in macOS. We do know that macOS is completely not vulnerable to anything. It's a very secure thing. So how is it possible to find something there? That's what we are going to hear during the next 45 minutes. Wait.
BSides Legacy.
Hello. Hello, fellow hackers. It's good to be over here. I'm really honored to see that there's so many of you over here. I want to give a round of applause for all the organizations and also the sponsors to make this event happen. So let's do that. All right, so I'm going to talk about macOS, some macOS vulnerabilities and walk you through what was happening under the hood when I found a couple of interesting vulnerabilities. But before that, a little bit about me. So my name is Mikko Kenttäla. I'm founder and CEO of SensorFu. We do product which continuously monitors how well the network isolation is working. But I'm not going to talk about that today. I'm more going to talk about my Happy Hacker hobby project, which is related to the vulnerability research. I have multiple hats in other organizations, and you can find me from the Twitter. Previously, I did research. I started to do some research related to the macOS when I got a little bit more time during the 2020 because of obvious reasons. So I had more. I didn't travel so much and had a bit more time to do and check out some of the things what I use myself. So I've been doing this since forever, that whatever software or operating system or applications I am using, I tend to check out that what is actually going on under the hood and what might be, maybe there's some security challenges. And I want to really know that how the things work. I've done technical security audits as a profession over 10 years, so maybe I'm not doing those that much anymore, but maybe that has something to do with it. So previously, I found a zero-click vulnerability from the macOS mail application, and you can find I wrote about it. You can find the blog from there. But basically, what that vulnerability was about was that I was able to craft an email as an attacker and send it to the victim. And immediately after the victim received the email, his mail application configuration changed in a way that after that, all the emails were also forwarded to me. So that was arbitrary file write issue in the macOS mail. So, but this time I'm going to talk about a little bit different case. It is actually a bit more complicated in the sense that it includes vulnerability chain, what I needed to exploit to gain the access to all the sensitive data what the user might have. I also walk you through about the different security methods, what actually is implemented in macOS, and I needed to circumvent those to actually achieve the goal. So I show you on video. This is actually the same video what I sent to the Apple. So it's the original version of the video to prove that there's some challenges. And I'm going to walk you through that what's happening on this video. So during that time, Big Sur was out there, or it's in the beta phase. I just show you that I have all the security mechanisms implemented in a way that it is enabled. So even if you open the terminal, you cannot access the files on your desktop or in the other folders because there's restrictions for that. So, however, in this case, when user downloads a specific file from the internet, it may be phishing or something like that, but in this case it's like a raw demo. It's downloading a zip file, and now the zip file is downloaded, and you saw the pop-up that do you really want to download it. And that's the one click which is needed from the user input. And next time when the user launches a terminal, something weird will happen, and you can see that your machine is owned and some databases has been taken, and after that it seems that there's now a terminal can now access to all the files in the different places. So something definitely went wrong because that should never happen. So a little bit about the background and how I normally operate. So I tend to find out different vulnerabilities in rather simple methods. There's 3 steps, and with the first one is quite obvious that try to learn as much as possible. And you can do that by reading the documentation, reading what's written at the internet about it, about the same thing what you are researching. And especially for me, the reverse engineering is the really key thing to actually find out that how different applications are working. So I normally use softwares, rather simple softwares. Maybe I'm old school guy, so I use dtrace, for example, tracing the syscalls in the macOS or other systems. I use tcpdump to see the traffic, and really advanced analysis methods like strings to analyze the binaries and so on. So rather simple things. But with that combined to the things what I play around and I see the results, what's happening under the hood, I can make up on my mind that how exactly the application or the service is working. Find the anomaly. When you know how the process or application actually works, if there's places for user input, so try to play around with the user input, see if you can cause some anomaly under the hood. So you have the visibility with the external tools for it, or maybe you get immediate feedback via user interface. But you try to play around and try to cause some error or something like that. And that might be it. That might be the actual vulnerability. Then when you have found it, do specific testing related to that anomaly and try to exploit that. So rather straightforward in the fundamentals, but might take some time to actually get it done. So to achieve code execution in macOS with one click, we need to really evade multiple different security mechanisms. And I quickly walk those through. So we need to find the anomaly, we need to exploit it. After that, if we want to get more done, we need to evade the Gatekeepper, which is, well, I explain it a bit later, which is takes care of that what application should be able to run on the system. There's an TCC, which is taking care of the restrictions and providing the sandbox in the macOS. And SIP is protecting most important files in macOS-based system. And its zip protection is built into the kernel, and the TCC is in the user land. So the Gatekeeper, the main role, if you use macOS, you might be seeing pop-ups like these. These are basically how you see the Gatekeeper in action. So whenever you download new binaries, you open things that you have downloaded from the internet, it is typically marked as an potentially malicious file, and the gatekeeper will trigger this warning to show you that are you really want to run this, and show a little bit of information about where you have downloaded it and so on. Then there's the DCC, which is basically controlling the sandboxing in the sense that you have sensitive data on your system, including web camera information, location information, your emails, your files, your photos. There's controls for all of that. And DCC is the component which basically is the user interface to control that data. So normally, when you run your application is only should be only accessing the files which are related to that specific application. If you need to access some files on your desktop or something like that, you really need to grant the permission for that application and provide the possibility to access the files in specific places. And this is rather a good thing to have in the macOS. Then there's the SIP, which is the System Integrity Protection. Here's an example what it does. So even though I have a file in my home directory, I cannot access it. So even though if I should be the owner, and from the Unix BSD point of view, I should have access to read that file, that SIP is protecting that file to be accessed by myself from the terminal. I need to use specific software to get the access to that specific database. So this is in kernel level, so it is making the attacker's life quite much more harder. So let's dive into the actual vulnerability chain. Now you have some understanding about the background. In this phase, can you raise the hand how many of you are actually using Apple devices or macOS? All right, about half of you, I would say. So quite many. So the vulnerability chain, alias file to rule them all. So in this chain, we will gain the access to compromise the user's sensitive data with the only one click, and meaning user interaction. So when the user clicked once, this pop up. After that, the game is over. So, in a nutshell, I showed the video. So when the user actually accepts the download, the zip file will be downloaded, and the macOS is infected. And what is happening under the hood? The zip file is in general considered as a safe file format in a macOS Safari at least, and also in some other places. So what that means is that when that is downloaded, it will be automatically uncompressed and extract to the downloads folder. So in my case, the zip file actually included an application with an alias file. And this is important because it needs to look like an application, because we want to, well, I'll explain it later on, but in that zip file, it's an application, and in macOS, the applications are just a bunch of directories in a certain structure, and instructions and the original binary. And I did it so that the alias file was the binary in that application. macOS alias files. How many of you have heard about the macOS alias files? Couple of you. Great. It is interesting because it's mostly promoted in '91 when it was originally introduced in the macOS 7, so quite a while ago. And the biggest benefit with the macOS alias files compared to the traditional links or symlinks or so on is the fact that it is pointer for certain objective in your system, object in your system. So even though if you move the original file to different place, all of these alias files will be automatically updated also. So you can move the original file from place to place and the links will still work or the alias files will still work. So it's quite an ancient history and still working well in the macOS system. I rarely see these in action. Maybe more in the, if you install a new application to the macOS and you do the drag and drop for the application and it points to the application folder, that's the only case where you see it, but you can use it for other things like a PDF or so on. So, the application normally includes the executable inside of the directory structure. And in my example, it was exactly over there where the alias was. So the main executable was the alias. But the trick in my case was that it was pointing out to the external resource. And this is one of the cool things about the macOS alias files is that you can actually do it in a way that it completely links to the some resource which is outside of your computer, like a Samba mount, for example. So I did that. And whenever that application inside of that zip is downloaded, there's a background process called LSD, launch service daemon, and it will automatically figure out that, oh, this looks like an application, I need to go and index that so we can launch it easily via other, like a Spotlight or something like that. You can launch it via that way. So it does it automatically. So with this way, attacker can trick the victim to download and automatically mount a network share. But that's not yet there. I was thinking of this was the original thing what basically gave me the idea that maybe this is something what should be looked more closely. This is not like this is a kind of bad thing, but not something what you can exploit immediately. So what? Now attacker can trigger Samba mount, but what can you do with that? You can try to fool out the user to actually click it, open some malware which is inside of that, but it will be prevented by the Gatekeepper because it's flagged as a potentially malicious file because it's downloaded from the internet. And on the other hand, victim need to do some clicking, so it's kind of boring way to approach it that way. Okay, and then there's finding a way that how we can affect to the that process when the mount is actually automatically mounted. So I was trying to figure out that what I can do with this capability right now. So I started to think about that it would be great if I can mount the Samba mount to some specific directory instead of normally used /volumes. And typically, when you install or double-click the image or the network share, it will be mounted under the /volumes. And the last part of that URL is actually used as the name of the directory. So obviously, I started to do some trickery with // type of naming and pretty much tried all kind of different kind of tricks. But none of the tricks actually seemed to work in a way that it would be beneficial for me. Except there was one anomaly. For some reason, naming logic was failing if I added %00 to the name of the last path of the URL. So that's null, typically, and it broke something related to the parsing in the background. So after that, when that triggered, after that, the naming for the volumes / the directory will use actually the fully qualified domain name in that URL, which basically, in my example case, is the fileserver.local. in that example case. So I started to figure out that, can I use that? Maybe there's some different code path actually in the background, and maybe I can play around with the domain name, although I was a bit worried that it is quite restricted what I can do with the domain names. However, I decided that I configure the wildcard domain name for this test, so it is more easily to go through different variations and so on. And it turns out that the fully qualified domain name is not sanitized by any means. So even though there was a really strict sanitation done for the URLs and the last part of the URL, there was no sanitation at all in a fully qualified domain name. So the solution looks like something like this. So there's quite a lot of going on. But at first, we break the default naming method with the setting the last part of the URL as a null. And after that, the green part is used for naming. That first part, I needed to use double URL encoding to make the DNS query actually work. So in that example, I leveraged the wildcard domain name in a way that I entered the /private/temp/test, and in the third phase, I added yet another null to actually terminate the parsing in a way that the rest of the fully qualified domain name was not used for the mounting. And after that, the mount point will be /volume/./private/temp/test. So now I have an arbitrary access in a way that I can mount the Samba mount to whatever path I wanted. However, there was a limitation on that only non-existing directories can be used as a mount point. And this will be important in later phases. So, phase 3. We still don't have a code execution, but we have the arbitrary mount path for the Samba mount, which can be triggered with the one click. So how we can get the code execution? This shouldn't be too hard in the sense that traditionally, in this phase, it's more like you just need to do a lot of reading and sitting and at your computer and just figure it out. However, it was surprisingly painful, and funnily, this was the phase which actually took most of the time in this exploit chain. So normally, there's a couple of potential paths what you can take when you actually want to find out way to get code running when you have that kind of like arbitrary file mount situation. So you try to find out what existing softwares there are. Maybe there's plugins or other features what you can leverage that whenever the software is launched, it will automatically load the plugins from specific directory and so on. However, there's plenty of speed bumps still to cover Gatekeepper, sandboxing, and the fact that the mount point directory need to be a new directory. There was plenty of options to actually get the plugins in and running while you are using normally some applications, but there was an existing directory, so I couldn't use that. So that was great limitation for me to actually figure this out. Just a reminder that Gatekeepper is the one which provides these pop-ups and prevent the external applications which may be malicious to actually run on your Mac. So, but I found a solution, and most straightforward way for this demonstration was to actually use z keyboard directory. It is a directory which includes normally, or could include normally, some configuration to your shell. So ZSH is the normal common shell in macOS nowadays. And if you have you can set up configuration files which are basically can be shell scripts, for example, to that directory, and those will be automatically loaded whenever the ZSH is initialized. So now we got finally we had the code execution capabilities, and we can get our own shell scripts running on the system whenever the terminal is launched. So, but then we had still the problem, and by the way, the Gatekeepper, because it is this is actually affecting to the existing software and the configuration in that existing software, meaning the ZSH and the terminal. So these are existing software, so whenever those are launched, the Gatekeepper won't prevent of launching those applications because it is original application, and we only infected the configuration which will cause the code execution. So what now? We still don't have the access to all the personal information what could be over there because of the TCC limitations. And this is, as a reminder, this is how the TCC looks like. It's taking care of the sandboxing related to the applications. So the TCC works so that all the user consent is actually stored in the SQLite in that specific path. All of the Mac users, you have that in place, and it includes all the configuration. It is SQLite, so it's not that complicated system, but it is protected by the SIP, so you cannot, in normal situation, you cannot manipulate it by any means, because SIP will prevent that. Even if you are root, you cannot access that. So this means we need to circumvent the SIP to get access to that TCCD. How hard it can be? The TCC actually works so that you have a user process called TCCD running, and it's owned by your user account. So I was thinking of immediately that, okay, basic Unix stuff, I'm the owner of that process. Maybe I can manipulate the environment in a way that something fancy will happen, and I can fool the TCCD to actually load some other SQLite database instead of mine. I am, and you as a user, you can kill the TCCD process, but it will be automatically launched immediately after you have killed it. But you are able to do that. The only restriction is that you cannot manipulate the TCC database because it's prevented by the SIP. So, I have to be honest, this was the first thing what I tried, and it worked. It might be hard to see, but I will walk you through. So, this was lucky strike for me because I was playing around with the mounts before in the previous phases. So this was the first thing what came to my mind. That what if I just kill the TCCD process and quickly mount a new image to that specific path, and that specific image will include my customized TCC database. And this was basically the first thing what I tried, and it worked. And I was really stunned that what the heck is going on, that this should be preventing all the attackers to stay in the sandbox, and this was the first thing what came to my mind. But it was a lucky strike, and if you do technical security audits, you find out that these lucky strikes are surprisingly common because for any reason. Or maybe it was a hunch that maybe I should try this because maybe the developers didn't think about this kind of scenario at all and turned to be that way. So TCCD process will start after I have killed it and mounted a new image to that exact path where the TCC database is. When the process will start again, it will just gladly pick the path, load the new SQLite database, and that's it. So now, whole puzzle was basically solved with this. And now we gotten access to all the files, and we are able to run code in the system in a way that there's attacker's Samba mount mounted to arbitrary file path, and the attacker has fully control, and it can do whatever the attacker wants. So this was rather complicated process in the sense that if we look at this, all the steps, so the user downloads the zip file, it will be automatically extracted by Safari. Then there's a LSD process which will automatically go and index it. It finds out that, oh, there's an alias file with the external resource. It will automatically mount that external resource because why not? And after that, we have an initial access. Then later on, when the user does some things, normal things on his or her laptop, like launch a terminal. I know this is not like a best scenario, but it was good enough for the proof of concept and the demo. When the terminal actually launches, it launches the ZSH, and it will load configuration for it, which actually includes my payload, all the shell commands, and that will be automatically done. And then we have the evasions for the TCC and the zip to actually gain full access to that terminal to access all the different places. And we are there. Then, this was basically done, the timeline. This was done during the 2020. I found the issue. It took quite a while to make it like a good proof of concept of it. I actually reported this to the Apple when the Big Sur was in the beta phase. Quite fairly quickly, they did the fixes. So both of the main vulnerabilities were fixed in quite quickly. The alias issue was silently fixed, so maybe they didn't consider that as a vulnerability, the fact that it will be automatically mounted if you have an alias file in your macOS application main binary. It's a functionality, I guess. So, however, they silently fixed it, and it's now all the over 100 million of Mac users are now in safe. It took all the way 1 year or over 1 year to actually qualify it for the Apple security bounty. So it's not the fast process. If you are planning to do some security research for the Mac OS, you shouldn't hold your breath and wait the Mac OS bounty to come. It will take some time. However, they pay at the end of the day, and it is like a fairly good bounty, I would say. And this is how the CVE actually looks like. So I think like over 5 years ago, especially in the Apple's case, these change logs related to the cybersecurity was always quite abstract, and it seems that the things have been going to the better direction. I'm happy about it, and they are actually quite well showing that what was going on, and it gives you a better idea that what is going on. And this is the other vulnerability related to that. I've asked quite a lot that how the cooperation with the Apple went, so maybe I cover it because I have some time. In general, I've reported also other not that serious vulnerabilities to Apple. In general, nowadays they reply rather quickly. They don't provide any information that how the research is going on. Only after when the issue is fixed and released, they give you insight that you were the first one to find that out and so on, that kind of information. But for example, in this vulnerability chain, they had some troubles or challenges to reproduce the Samba mount case. So we basically cooperated, had a chat via email, and after some discussions, I just decided that I built a virtual machine for them, which has the pre-configured Samba server and so on, and they were able to reproduce the exact issue. So I think it's fairly good because they can do the fixes in a really short time, 2 to 3 months, and those are pushed to all the users. That's a good thing. Obviously, the bug bounty part will take a heckload of time. That's something what most of the researchers complain, but at least there's a bug bounty program. So I think that's great. Okay, but I think that's about it. Thank you, everyone, and I'm really happy to hear if you have any questions. Thank you.
So, any questions from the audience? There is one here first. And the next one can also show their hands, so the microphone can move during the answering and we get faster. So, please.
Yeah, based on your presentation, the security research is like a walk in a park. You just find one vulnerability, then the next one, etc. Especially the phase 4 with the lucky strike. But how many dead ends you met per phase before you actually got the successful exploit working?
Quite many. So in all the phases, basically, I looked around quite a lot. So except the lucky strike, that was like went right in the first try. But I would say it's like a 1 to 10 ratio. I tend to operate in a way that I try to poke around to find out a hunch that what might be the next step. For example, I went quite far with one of plugin type, which is related to the macOS preview. So whenever you, if you have a picture in your desktop and if you press space, you get a preview about that file. So there's a plugin system in that preview. So I went quite far with that, but it is really heavily sandboxed and really limited. But I spent many, many evenings with that and then decided to just to take a step back and try to poke around the other things, and it started to go forward. But it is really common to, so for that reason, I try to operate in the way that when I go and poke, and okay, this feels a bit soft, let's see how far I can push it, and if it starts to be harder, I maybe come back and try something new in the next day, and maybe come back to that same topic again later on. So it's like really common. And about the comment related that it seems that you just walk through the different paths and look around at what you can find, and that it seems for me that there's not too many researchers doing that kind of things because it's manual labor. Basically, you cannot easily automate this and automatically find out these logic bugs. What I basically used, all of them are like a kind of logic bugs. There's more research on the things what you can do automatically, fuzzing, for example, which is still really effective, and so on. So that's something what you can also do. I think I felt that these challenges, puzzles, what I was able to solve was more like playing or capture the flag or doing that kind of challenges.
Hi. So in the URL encoding part, in the Samba part, you URL encoded the path traversal, and I understand that. But what really surprised me is that you double URL encoded and it double URL decoded. Why do you think it did that?
I'm not exactly sure, but if I use one layer of URL encoding, I think it broke the DNS query because it includes the dots or slashes. Maybe those are not valid like a DNS queries. Most likely some of you know about that. So for that reason, I needed to use the double encoding. And I'm not sure what actually happens over there. It might be, I don't remember. I've been checking that. So most likely what happens is that the first layer of the encoding is removed immediately in the first phase when the DNS query is done. So the one layer is removed immediately, and when the in the next part, when that same information is used again, then the second part will be removed. But not sure. But it is fairly interesting and fairly old trick to fool the parsers, I would say also, to have the double encoding.
Thank you.
Next microphone is already there.
What recommendation can you give for the newbies who wants to start the bug bounties? Do you say that Apple bug bounties are harder to find than Windows or some others?
Depends on your background. So if you are Unix sysadmin, if you have any experiences of hosting a own Linux server or something like that, the macOS is good because it's working as traditional Unix systems under the hood most of the time. There's some flavors for macOS, like the security control mechanisms and so on. But the fundamentals are the same. But for the newbies, I would start with something maybe smaller, because the operating system includes quite a lot of new things. If you know something already about the OSs, not from the security point of view, but that if you know already how the system should basically work, it is definitely easy to dive into that topic. But if you are, it might be for total newbie, it might be more, you might be much more successful if you have a smaller scope, maybe one application or one service, and you learn that first and go piece by piece later on. So maybe that would be. But in general, hacking the Windows or hacking the Mac OS, I don't see much of difference. I tend to approach it in the way that I don't do the same things what the others are doing. So there might be low-hanging fruits on the places where nobody is looking at. And this is one of the examples. It seems that everyone who is doing seriously some vulnerability research and bug bounties, they are really into running automatically and systematically fuzzers and doing testing that way. So I just thought that maybe I should take a totally different approach and look to different direction. And it seems that in general in cybersecurity scene there's like a Sauron's eye, which is like in the Lord of the Rings, that it's turning always to some direction and everybody is doing similar kind of things. So I've been always trying to pick the leftovers, because it seems that there's plenty of research to do in those avenues also. So maybe that's something to consider if you want to really get the bounties also. Maybe do something what the others are not doing.
And there is one more question there. If there is another hand, just show first.
Yeah, hi. Your disclosure timeline started with the actual disclosure to Apple, but I was wondering, before the time of disclosure, how long were you working on that specific series of events, and was the time spent in proportion with the bug bounty from Apple?
The main alias thing is really old one. However, I didn't, if you remember where we started in the phase 1, it didn't lead too far. So originally, like 2015, I found out that you can sometimes automatically have a disk image mount if you are using the alias. So that was something which was on back of my head, that this is something what need to be researched when I have a time. And immediately after 7 years I had more time, or the 5 years I had more time for it. So, but when I started to do that, when it started to go forward, I started to get some results, and for me, I think I spent the evening time mainly with this, so 3 hours per evening, and it took something like 2 weeks to go it through during the evenings, and my family had to be quite flexible, because when I saw that this is going to some direction and I cannot stop it now because it's like all the time on my mind, so I need to solve this puzzle. And at the same time, it's rather serious thing if you can do that kind of thing. So I felt that burden of 100 million users, that maybe this should be fixed in a quite quickly. So 2 weeks about was the timeline for it.
Okay, we have one more question from there, and then there is a time to pick the winning question.
Since this exploit is like from a user land and start with a single click, do you think is it possible to get it to a zero-click state by using a WebKit exploit?
Yeah, it could be. So actually, it went so that this actually refers to the previous question too, that this is the thing what I started originally. So I started to do the research for the alias. I started to try to find out the zero-click possibility. I ended up finding the mail vulnerability, which was zero-click. So I had a struggle inside of my mind that should I just combine these or get it working in a way that with that email I will cause. But during that time, I didn't have full chain for this specific thing. However, the mail vulnerability was so big and concerning that I didn't want to sit on top of that vulnerability because after all it was zero-click and it was existing and there's quite a heck load of users using the Mail app. So I made a simple proof of concept for that and sent it to the Apple and continued with this and started to think about that maybe this is like another chapter. So definitely it could have been triggered via that way.
Okay, thank you, Mikko, first. There's also goodie bag for you.
Thank you.
And which of the questions you like most? I think there was kind of like the URL, the final one, then the kind of getting started.
I think the how to get started with the bug bounty is a good thing because one of the great motivations for me to come to speak about the vulnerabilities to this kind of events is to encourage the younger who are coming to the business to actually do some security research. So I think that's the best one.
Okay, Alo can find later the volunteer who will help. So
Thank you.
And we have a coffee break of 26 minutes left. We'll be back here at 15:30. And then we'll have two more legends of cybersecurity going to talk to us about thinking models based on Mitra attack and different tools that do or don't do the work for you. So see you back in 20-some minutes.